Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. There are 10 squares in total, so each square is worth 1/10. And if we count all of the shaded squares, we notice that in total there are 7 shaded squares. So that's 7 lots of 1/10 or 7/10. The range is just the biggest number, take away the smallest number. Biggest number in this list is 15. The smallest number in this list is 3. So 15 take away 3 is 13. So the range is 13. For this question, we're going to have to remember BIDMAS or BODMAS. So we're going to first of all look and see if we've got any brackets. Well, we do. We've got the 11 squared minus 21 in brackets. So we're going to be looking at that bit first. Inside the brackets, though, we don't have any brackets, but we do have an indice. We've got that 11 squared, so we're going to deal with that first. So 11 squared is 121. So we've got rid of the indice, but we're still looking at the bracket. So we're going to do 121 minus 21, which is going to be 100. Now we have no more brackets, no more divisions, but we do have a multiplication. So it's going to be 300, and that's our answer. Median just means middle, but it's the middle of the ordered list. So the first thing we need to do is put these numbers in order. So we're going to have 2, 4, 5, 6, 7, and 9. And to find the middle, what we do is we cross off the smallest and the largest, and we put our pen away. Then we do the same thing again. Smallest, largest, pen away. Now, you see here that I can't cross out the smallest and largest because that will leave no numbers at all. So when you're left with 2 in the middle, all you need to do is add them together and divide by 2. So 5 plus 6 is 11. And 11 divided by 2 is 5.5. And if you look, 5.5 is exactly halfway between 5 and 6. I'm going to start just by writing down the number. And we're asked to round this to 3 significant figures. And basically what that means is starting from the left-hand side, it's 3 numbers that we want. So 1, 2, 3. And we're going to do our line after that third number. And you start counting the first non-zero digit. So the first digit there was 2, so we started counting. Now all the numbers to the left, or sorry, to the right, so these numbers here, will all turn to 0. But before that happens, we look at this number. Now this number, if it's 5 or more, it moves this number up by 1. If it's less than 5, that number stays the same. Now it is 5 or more, because it is 5. So it's not going to be 207, it's going to be 208. Now, a common mistake is that students write down 208. No, all the numbers to the right of that line turn to 0. So it would be 0, 0, 0. So it would be 20,000 or 208,000 exactly. So if we just add the amount of sides each of these shapes has, a triangle has 3 sides, quadrilateral 4, pentagon 5, hexagon 6. And notice what's happening with the number of edges. They're multiplied by 3. Each time they're multiplied by 3. So all we need to do is get the 15 multiplied by 3, which will be 45. So there will be 45 edges. So what we can do here is we can do 3 divided by 7 to find out what 3 is a percentage of 7, find out what that is as a decimal, which would be 0.428 blah blah blah. And then to convert a decimal into a percentage, we times by 100, so we can get that 0.428 blah blah blah, and we're going to times it by 100, and that will be 4 of 42.857, and it wants it to the nearest percent, so that's going to round to 43%. We're going to start off by finding what the multiplier will be. So we will start off with 100%, and it's a decrease of 32.6%, so we're going to take that away, and that will leave the percentage as 67.4%. Next we need to convert that into a decimal. So we're going to divide it by 100, and that will make it into a multiplier. And the beauty about a multiplier is all we need to do is get the amount from the question, 486, and times it by the multiplier, and it will do all the hard work for us, and it will give us the answer of 327.56. So adjacent angles in a parallelogram add up to 180, and the reason for that is that we've got a set of parallel lines here, and both of these angles are within that set of parallel sides, so they're actually co-interior, interior, or allied angles, whichever you choose to call them, and so we know that they're going to add up to 180. So we're going to do 180, take away the 61 we already have there, which is 119. So our answer is 119 degrees. So the only options for the next card are for them to be higher, lower, or equal to 12. We already know that the probability for it being higher is 19% and lower is 28%, and all probabilities have to add up to 1, or in this case, because it's percentages, 100%. So to work out the probability that is missing, we're going to take away the 19% and the 28% away from 100% to see what's left, and that's 53%. The formula for the area of a triangle is half times the base times the height. Now the base is the normally the length on the bottom, but that's not always the case. The important bit though is that the base and the height hit each other at 90 degrees. So this length here is not going to be the height because it hits the base at an acute angle. If we look, it's here. Same with the one on the left. The height is obviously going to be this length here in the middle. So let's put that into our formula. Half times the base, which is 5, times the height, which is 3. So it's going to be half times 15, and that will equal 7.5. Both the length in the diagram are centimetres, therefore the area will be centimetres squared. I'm going to write the expression given to us, but with times signs in, so it's 2 times x plus 15 times y. And it says that x is minus 3 and y is 4. So instead of x, we're going to replace it with a minus 3. And I'm just going to put it into brackets just to make things a bit easier. And instead of y, we're going to write a 4. So here we've got 2 times minus 3. A positive times a negative is a negative. And 2 times 3 is 6. Plus, and we've got 15 times 4, which is going to be 60. So we've got minus 6 plus 60. A different way of doing that is 60 minus 6 gives you the same answer, which is going to be 54. To see if a number's in a sequence, we get the nth term and we get it equal to the number we think is in the sequence. And if the number is in the sequence, then we'll get an integer for n. If the number's not in the sequence, then we'll get a decimal. So we're just solving this now, and we're doing 135 take away 24, which is 111. And then we're going to divide both sides by 10, and you're probably already seeing the fact that it doesn't work exactly because n is 11.1, which means that Prisha is wrong. 135 can't be in that sequence. To work out the area of a rectangle, we just multiply the width and the length. Here they are mixed numbers, so all we do is the width times the length. Now when you multiply with fractions, always make them top heavy first, or improper, and to do that you times the big number by the bottom and add it to the top. So we're going to do 1 times 2 and add it to the top, so 3 over 2. Same with this one, 1 times the 3 at the bottom added to the top. 1 times 3 is 3, add to the top is 5. Now we've got to get the numerator, we don't need to get the numerator the same, we're multiplying. All we do now, really easily, is just multiply the tops and multiply the bottoms. So we've got to convert 15 over 6 into a mixed number because it asks for a mixed number. So 15, how many 6's go into 15? Well, we're first of all going to have 2 whole ones. And how many left over? There are going to be 3 left over. Now, 3 over 6 is the same as 1/2 because we can divide top and bottom by 3. So our answer is 2.5. So we're given 21:4 is the ratio. And we're just going to have our lines in, because what we need to do is make the left hand side be 1. Okay. And to do that, for 21 I need to divide it by itself, divide it by 21, and we're going to do the same to the right hand side. So 21 divided by 21 is 1. Perfect, that's what we wanted. 4 divided by 21 is 0.190 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. To find average speed, we do the total distance and we divide it by the total time. Now in this question we've got a bit of an issue because the question wants kilometers per hour, but the units are given to us in meters and minutes. So we just need to do some basic conversions. So 1080 meters is going to be 1.08 kilometers because there are 1,000 meters in a kilometer, so all we need to do is just divide the meters by 1,000. Minutes are a little bit trickier. To get from minutes to hours, all we need to do is divide by 60. And so when you divide that by 60, you get 0.2 hours. So we're going to put the kilometers at the top, 1.08, and we're going to divide that by the hours, which is 0.2. When you do that, you get 5.4. So our answer to 2 decimal places will be 5.40. Whenever you have a one-digit number or a 1 decimal place number, but you're asked to round it to 2 decimal places, you should really put a 0 on the end, which is what we've done. I'm going to start by doing a multiplication grid. And we're going to be multiplying the algebra together. So we're going to do the x plus 2 at the top, and then the x and the minus 12 down the side. Multiply them together, so x times x is x squared, x times 2 is plus 2x, x times minus 12 is minus 12x, and then minus 12 times positive 2 will be minus 24. Put the terms together, and we'll notice that we've got 2x terms there. Got the 2x and we've got the minus 12x, so we can collect like terms. And so here it will add together to make minus 10x. And that's our answer. So our answer is x squared minus 10x minus 24. There are 2 rules for things to be in direct proportion. The first rule is you must have a straight line, which we do on this question. The second rule is it must go through the origin. So we're looking for a line like this or like that, somewhere in that region there. Now this red line does not go through the origin, so A and B cannot be in direct proportion. Whenever you have north lines, they will always be parallel. So what we have here is we have a straight line going through 2 parallel lines, which are our 2 north lines, and therefore this angle here is going to equal this angle here. And the reason for that is that the 2 angles are alternate, they're Z angles. So we can say that that is 135, and I always like to try and show the examiner the reasons. So that's because it's alternate angles. And we know also that angles on a point add up to 360. So this red angle represents the bearing of A from B. And so to find this angle out, what we're going to do is just 360 take away 135. And the reason for that is angles on a point equal 360 degrees. And when we work that out, we get the answer of 225. So our bearing is 225 degrees. It doesn't look like it, but we actually have a quadratic here. And the reason it doesn't look like it is because we don't have an x term. But as long as we have an x squared term and a number term, we definitely have a quadratic. And notice something about this second number. It's a negative version of a square number, and that will always be the case because this question is using something called difference of two squareds. And it's very, very simple to work out. What you do is you put down two sets of brackets and you square root the first term. Well, that's just going to be x. And you put the positive and negative versions of the square root. So we're going to square root 121, which is 11. So we're going to put plus 11 and minus 11, and that's it. Now, when we expand that, and we're just going to quickly expand that now to have a look, it's going to be x squared plus 11x minus 11x minus 121. And notice that the two x terms cancel each other out, which is why we don't have the x terms. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.